Hi, math students. It's Mrs. Marcellus and my really wise friend, Euclid. Today we're going to find the area of trapezoids. Today's learning objective is students will find the area of trapezoids by creating models and applying a formula. Before we start calculating the area, first let's take a look at just what is a trapezoid. A trapezoid is a four-sided figure, so it is part of the family of quadrilaterals. A trapezoid is a special quadrilateral because it always has one set of parallel sides. The parallel sides are called the bases, and we mark them as base 1 and base 2. A trapezoid also has a height that connects the two bases. And of course, the bases and the height are going to be important in deriving our formula for finding the area of trapezoids. Shall we go figure out how to find that formula, Euclid? He says he's ready, so let's move on. If we take any trapezoid, duplicate it, and flip it over, then match it up to the original trapezoid, we will end up with the shape of a parallelogram. Every trapezoid is actually half of a parallelogram. If we look at our overall parallelogram shape, we know that the area of the shape is going to be the base times height. To find the area of that parallelogram, we will first have to add base 1 and base 2 together to get the full length of the side. Then we will multiply that times the height. The original trapezoid is only half the area of that parallelogram, so then we'll either have to multiply by 1/2 or divide by 2. The area of a trapezoid is always 1/2 of a parallelogram, so the area of a trapezoid is 1/2 times the bases added together times the height. This is very similar to finding the area of a triangle, which is 1/2 times base times height, but with the trapezoid, you have to remember to add the two bases together first. Let's take a look at some examples. To find the area of this trapezoid, we can apply the area formula. There are two common ways to write the formula. The first is to multiply 1/2 times the two bases added together times the height. The second is to add the two bases together, multiply that times the height, and then divide by 2. For this first example, I'll show you how to solve using both formulas. First, we need to identify the bases and height. The bases are the two parallel sides, so that would be 6 and 10. The height connects the two bases together, so the height is 4. Using the formula on the left, we would write this as 1/2 times the two bases added together, so that's 6 plus 10, times the height of 4. Because they are in parentheses, we must add the bases together first. This leaves us with 1/2 times 16 times 4. When we multiply 1/2 times 16, we're left with 8 times 4, which equals 32. Since multiplication is commutative, you could have switched the order of it and still arrived at the same answer. An alternate way to apply this formula is to turn 1/2 into the decimal 0.5. You can then multiply 0.5 times 16 times 4 to get the answer of 32. Applying the formula on the right, we will start by adding the bases together, 6 plus 10, and multiplying by 4. We will then divide everything by 2. Because they are in parentheses, we'll start by adding 6 plus 10. This gives us 16, which will multiply by 4 to get 64 as a numerator. We will then divide by the denominator of 2. 64 divided by 2 equals 32. Regardless of which formula you choose to apply, you will find that the area of this trapezoid is 32 meters squared. Let's try another example. Since there are 4 dimensions given for this trapezoid, we will first need to identify the bases and height and which dimension is not used. The bases are the parallel sides, so those would be 14.2 and 7.5 feet. The height always meets the bases at a right angle or is perpendicular to them, so we know that the height is 3 feet. 4 feet will not be used in our calculation. To find the area, we will apply a formula. I'm going to use the version on the right. We will add the two bases of 14.2 and 7.5 together, then multiply them by 3 and divide by 2. The two bases added together equal 21.7. 21.7 times 3 equals 65 and 1/10. Then we'll divide this by 2. We find that the area of the trapezoid is 32 and 55/100 feet squared. An owl built its nest in the shape of a trapezoid. The bases measure 16 inches and 27 inches. The height of the nest is 14.5 inches. What is the area of the owl's nest? It is always a good strategy to draw a picture. However, since we've worked with pictures throughout the video, for this example we will just pick out the important information and plug it directly into the formula. The problem tells us the bases measure 16 inches and 27 inches. The height of the nest is 14.5 inches. Using the second formula, we would have the area equals 16 inches plus 27 inches times 14.5 inches divided by 2. First, we will need to add the two bases since they are inside the parentheses. 16 plus 27 equals 43. Then we multiply 43 times 14.5. This gives us a result of 623.5. We then need to divide that by 2. That gives us our final answer that the area of the owl's nest is 311 and 75/100 inches squared. Wow, Euclid, that seems like a pretty impressive nest. How about you? Do you have a really large nest like that? Oh, yours is in the shape of a dodecagon, huh? That seems pretty fancy. Well, math students, this does conclude our lesson on finding the area of trapezoids, so we're waving bye for now.